Hi, this is Hussam Ghanem, and now I'm going to help you with optimization. In this problem, we have a rectangle inscribed within an isosceles right triangle. The hypotenuse of the triangle is 2 units. Okay, it's between -1 and 1, so it's 2 units. So A asks us to find. It says express the y coordinate of P. P is this point over here. P in terms of x. In other words, find the equation of the line AB. Okay, so first we have to find the length of this side. Well, since it's an isosceles, we can call this one A, and this one is going to be A. So it's going to be A squared plus A squared is equal to 2 squared, which is 4. Okay? 2A squared is equal to 4. A squared is equal to 2. A is equal to plus or minus square root of 2. Since we're talking about lengths, it doesn't make sense to have a negative distance, or a negative length. So we're going to ignore the negative. So it's just positive root 2. Now, we have the length of the hypotenuse over here. Now we're interested in this middle triangle to find the y, the length of y. Okay, so if this is 1, so it's going to be 1 squared plus whatever y is, y squared, is equal to root 2 squared, which is going to be 2. Okay? 1 squared is just 1. So y squared is equal to 2 minus 1, which is 1. Y is equal to plus or minus root 1, which is 1. Right? Of course it's 1 because it's in the positive direction. If this was 0, 0, then this is going to be 0, 1. Now, we have all we need. We have the y-intercept, and we have the slope because it goes down 1 and right 1. So it's going to be -1. Okay? So the slope of the line is -1. We have y equals -x plus 1 because it passes through the y-intercept at 1. Now we have the y. We solved A. For B, it says express the area of the rectangle in terms of x. Well, if the distance from here to here is x, right, and here to here is x, then the whole width of the rectangle is 2x. So area in terms of x is equal to 2x times, well, the height of the rectangle is going to be whatever this point is. If you can imagine it, if this point moves on the line, then the rectangle will shrink or expand. So it would be the equation, the y of the rectangle is going to be the equation that we just found here for y. So it would be minus x plus 1. Right? Okay. Of course, if you want to do some more algebra, it's going to be a of x is equal to, you distribute -2x squared plus 2x. So, the third question says, what is the largest area the rectangle can have, and what are its dimensions? So to find the largest, the maximum area, we have to take the derivative of the area. See, since this is a parabola, and it's, of course, it's a negative, so it's an upside down parabola, the derivative at the top will equal to 0. That's why we have to find the derivative and then set it equal to 0 to find the candidates. So dA dx is equal to negative 4x plus 2. Okay? Now, when is this equal to 0? Well, I'm just going to do some algebra in my head. So it would be just x is equal to, if you subtract 2 and then divide it by negative 4, it would be 2 divided by 1/2. Okay? Now here, when x is 1/2, the derivative is 0. How do we know if it was a maximum? Because the candidate says the endpoints are also included. What are the endpoints? It's negative 1 and 1. So right now you can just imagine that if it was negative 1 and 1, then it wouldn't have any height, so it wouldn't have any area. So it doesn't make sense to have negative 1 and 1 as candidates. So this is the only candidate. But we can also prove it using the second derivative. The second derivative will determine if the function is concave up or concave down, which will tell us if we have a minimum or a maximum. So the second derivative would be just d 2a dx squared is equal to what? It's just going to be negative 4, right? So it is less than 0. d2a dx squared is less than 0. Therefore, the graph of the area is concave down, right? It's a negative. It's concave down, just like we drew it over here. So, therefore, or as mathematicians write, therefore, it's 3 dots. When x is equal to 1/2 the area is at its max. Now it says what are its dimensions? Right, we found when it could be the largest. Now, what are the dimensions? Well, you just plug in 1/2 into the area, or as we said, 2x is the x dimension, and negative x plus 1 is the y direction, or the height. So the dimensions are going to be width is equal to 1 unit, and then the length is going to equal what? Negative 1/2 plus 1, it's like 1 minus 1/2, so it's 1/2. There we go, we solved it.